This video goes over factoring simple trinomials. This is a method that we can employ when we can't common factor, or we can make things simpler than just common factoring. So first of all, let's expand to look for some clues to help us factor. So expanding, we can use FOIL. So this would give us x squared plus 4x plus 3x plus 12. Collecting like terms will give us x squared plus 7x plus 12. Kind of interesting that we're adding, okay, we're multiplying those two outside terms and then adding them together. Let's do another one. First, outer, inner, last, x squared minus 5x plus 3x minus 15. So this is going to give us x squared minus 2x minus 15. Again, our last term is our last two numbers multiplied together, and our inside term is adding those two together. Let's try another one. X squared minus 2x minus 7x, and then plus 14. Same pattern. Our middle term is the sum of our two numbers, and our last term is the product. Let's do one more just for good measure. X squared plus 4x minus 9x minus 36 gives us x squared minus 5x minus 36. Again, our inside term is the sum of our two numbers on the end, minus 9 plus 4, and our last term is the product. So when we're trying to factor a trinomial, we're trying to find two terms whose product is C and whose sum is B. So let's take a look at these ones. We're going to factor if possible. So what we're going to start with is by finding all the ways to get to positive 8. So I'm going to write down just all the factors first. So 2 and 4. And then I'm going to check. So I've got 2 times 4 is 8, and 2 plus 4 is also 6. So I can factor this trinomial as x plus 2, x plus 4. Now if I check by expanding, I would get x squared plus 4x plus 2x plus 8, which simplifies to x squared plus 6x plus 8. Same as I started with. Let's try another one. So I'm going to start off by writing down my factors of 18. So I would start 1 and 18. Is there any way I can get those to add to minus 11? No. My next one would be 2 and 9. Well, I can get those to add to minus 11 if they're both negative, which also multiplies to positive 18. So now I found my two factors, x minus 2 and x minus 9. Let's try another one. Here I'm looking for two numbers that multiply to minus 21 and that add to minus 4. So let's start with my multiples of 21. So I've got 1 and 21. No way I can get those to add to 4, so I'll put an x. 2, 3, and 7. Could I get those to add to negative 4? Sure, if my 3 is positive and my 7 is negative, which also multiplies to minus 21. So now I know that I have the right combination, and I can put in my factors. X plus 3, x minus 7. Let's try another one. Here I'm looking for two numbers that multiply to minus 42 and that add to minus 1. So multiplies to 42. 1 and 42. No way I can get that to add to minus 1. 2 and 21. Also nope. What about 6 and 7? Those could add to minus 1 if I had positive 6 and minus 7, which multiplies to negative 42, which is what I have in my question. So then I can write in my two factors, x plus 6, x minus 7. Another one down here, multiplies to minus 20, adds to minus 8. 1 and 20, no way. 2 and 10, that one holds some potential. If I have minus 10 and positive 2, adds to minus 8, and multiplies to minus 20. So now I found my factors, x minus 10, x plus 2. Let's try another one. This is a little bit trickier because what we have here is not a regular polynomial. So here, I'm going to factor out minus 1. That's going to let me rewrite my equation by flipping all the signs, which then means that I can now factor. I'm looking for two numbers that are going to multiply to minus 12. Multiplies to minus 12 and adds to positive 7. So hopefully you're starting to see a pattern, and you can think about that if I get, well, let's see, my first thought would be 3 and 4. Those can only add to 7 if they're both positive. But that doesn't work because I need a number to multiply to minus 12. So let's try. What are my other factors of 12? I would have 1 and 12, 2 and 6, 3 and 4, 4 and 3. I already have that one. And that's it. So none of those can factor. So this is actually not factorable further because there are no combinations that satisfy multiplying to minus 12 and adding to positive 7. Let's look at another example down here. Here we're looking for two numbers that multiply to minus 6 and then add to minus 5. So multiplies to minus 6 and adds to 5. The first ones that I would think about would maybe be 3 and 2. But those can only add to 5 if they're both negative. Multiplying two negatives together gets me a positive. That combination doesn't work. What about 5 and 1? Does that work? Well, it would if I had 6 and 1, so that it would multiply to 6 and 1. Can that add to negative 5? Sure, if minus 6 is negative and 1 is positive. Adds to negative 5 and multiplies to negative 6. So those two, x minus 6 and x plus 1, have to be my factors. Okay, two more examples here. We've got x squared plus 16x plus 15. So two numbers that multiply to 15 and add to 16. So when those numbers are close together, you should be thinking about the combinations with the 1. So 15 and 1. Those will both add if I have positive 15 and positive 1, which does multiply to positive 15. So then I found my factors, x plus 15 and x plus 1. Okay, last example here. Two numbers that multiply to 10 and then add to minus 11. So multiplying to 10, I would have 1 and 10. If those are both negative, they'll multiply to positive 10 and they'll add to negative 11. So now I found my factors, x plus 1, or excuse me, x minus 1 and x minus 10. One easy way to check your answer is by substituting 1 for the variable to see if both expressions simplify to the same value. So let's factor this expression here first. We're looking for two numbers that multiply to minus 18 and add to positive 7. So multiplying to 18, I'm going to use 9 and 2. I want 9 to be positive and 2 to be negative. So we would have x plus 9 and x minus 2. Great. So check in my actual equation. I would have 1 squared plus 7 times 1 minus 18. So 1 plus 7 is 8, minus 18 is minus 10. 2, I'm going to check my factored expression. 1 plus 9 1 minus 2. This is also going to simplify to minus 10, so then I know I have the correct factor. Moving on, here we're going to take a